Section 5.5 is the last section we're going to cover. It's on page 351. It talks about the area of a region bounded by two graphs. So this is the mathematical aspect of it. And in the next lecture on this section, I will talk about the application and what it means. For now, we want to do the math part. And suppose you have two functions in which this function f of x is always bigger than g of x on some interval between a and b. The key for you is to kind of glance at it, kind of thinking if I put a vertical line, and we're going to only use that in this class. So a vertical line, just make sure that the top is always the same function and the bottom is always the same function. And the way it works, when you integrate still between a and b to find the area, you want the top minus the bottom all the time, no exceptions. So on the first set of problems, they give us the graphs. That's really good. It says find the area bounded by the two functions. Well, again, if I imagine, again, you don't have to do this, but it's a good idea. If I put a vertical line here, I notice the top is always the gray, which is g. Do you see that? And the bottom is always the parabola. So it says find the area. Area is the integral. The top, always the top, the gray, which is 2x plus 5 minus the bottom, which is x squared plus 2x plus 1 dx. And this is going to run from -1 all the way to 2, as you see. And that'll pretty much be it. Now, if you clean this up a bit, that would be 2x plus 5 minus x squared minus 2x minus 1. So that's the antiderivative of negative x squared. Those cancel out. Plus 4, right? From -1 to 2. And this is going to be what? Negative x cubed over 3 plus 4x evaluated from -1 to 2. That is f of -2, that's -8/3 plus 4 times 2, 8. Minus f of -1, that's 1/3 minus 4. And if I throw this in my calculator, I can get the final answer. -8/3, oops, plus 8 minus parentheses 1/3 minus 4. 9. There we go. That's what that area equals. And if I look at this graph, again, the catch here is for you to know what is what. There's an x squared and x cubed. So x squared is really this graph. Oh, I'm sorry, take that back. X squared is f of x. It's really that graph. And x cubed is really that graph. So if you put the vertical line, you notice area is going to be the integral, and it's going to be from 0 to 1, obviously. And the top is the purple minus the orange. And that's going to be what? Well, that's going to be x cubed over 3 minus x to the 4th over 4 evaluated from 0 to 1. Throw the 1 in. Minus, if you put 0, you get 0. So that would be all over 4, 1/4. I'm sorry, all over 12, 1/12. You could do that on your calculator, that's not a problem. Next problem. If I look at the first graph, and let's say that's f of x, and they tell me where it is, it's right there. And if they give me the second graph, and the second graph happened to be x minus 1, that's a straight line. I know what that looks like. So if I want to find the area, that's going to be the integral. And notice here what the problem is. If I went from -1 to positive if I run from 0, I'm sorry, x equal, it's always x equal, 0 to 1, from 0 to 1, do you notice the top is always the purple? And the bottom is always the line? Plus, when I run from 1 to 2, do you notice on this, the top is the line now? And the bottom is the cubic. So the order of those is extremely important. And that would be the integral. So if I say on the exam setup, do not solve, that's all I want. And that would be the integral from 0 to 1. And let's see how this works. X minus 1 cubed minus x plus 1 dx plus the integral from 1 to 2 of x minus 1 minus x minus 1 cubed dx. That would be, if I let u equal x minus 1, du is dx. So that becomes the integral of u cubed du. Add 1 to the power, divide by that. So this is really u, which was x minus 1 to the 4th over 4, minus, add 1 to the power, divide by that. Evaluate it from 0 to 1, and this is the same. This is x squared over 2 minus x minus 1 to the 4th over 4. Evaluate from 1 to 2. So this will be, throw the 1 in, you get a 0, plus 0 minus 1 half, plus 1, minus, if you throw the 0 in, that's negative 1/4, negative 1 to the 4th, plus minus 0 plus 0. Okay, I got that part. I'll throw that in my calculator. The blue part, throw the 2 in, you'll get 4 over 2, which is 2 minus 2 minus. If you put a 2 in there, 2 minus 1 is 1 to the 4th over 4. Minus, if you put the 1, you'll get 1 half, minus 1 minus. If you put a 1 there, that's going to be 0. And if I throw this in my calculator, pretty much I'm done. Let me get my calculator out. And I'm looking at, let's see, parentheses, negative 1 half plus 1 minus 1/4 equals plus parentheses 2 minus 2, I know that's 0, minus 1 divided by 4 minus 1 half. Of course, you could do this by hand if you wish. And I'm getting a 0.5 or simply 1 half. Either or. It makes no difference. And there it is. On the next section, they want us to sketch a graph. Well, do we know how to graph? Of course we do. The graph of y equal x cubed minus 3. A cubic shifted up 3 units. 1, 1. Negative 1, negative 1. The graph looks like this. And this. Okay. And they want us to do y equal x. Y equal x is a line that runs at 45 degrees. So right there. Starts at 0 with a rise 1, run 1. They want us to cut this off between x equal negative 1 and x equal 1. And do you see the region they're talking about? They want us to find this area. And how do you do that? Well, it's fairly simple if you think of, again, the vertical. Do you see the top is always the purple? And the bottom is always the blue? So, this is a negative x cubed plus x, and this is x. So, wouldn't the area equal the integral from negative 1 to 1 again? They told us those. The top is the purple. The top is always going to be negative x cubed plus 3 minus the base. Isn't the base just the line y equal x with respect to x? So this is the integral from negative 1 to 1 of negative x cubed minus x plus 3 dx. That would be negative x to the fourth over 4 minus x squared over 2 plus 3x divided from negative 1 to 1. Throw the 1 in, negative 1/4 minus 1/2 plus 3 minus a negative 1 in, negative 1/4 minus 1/2 minus 3. I get my calculator out, throw that in, and I'll get a negative 1/4 minus 1/2 plus 3 minus, make sure to use parentheses, a negative 1/4 minus 1/2 minus 3, 6. There it is, done. So what's the important part? The setup. If I say setup, do not solve, that's all I want. How about this problem? This is a bit more general, and let me use different colors to show those. It says sketch a graph of y equal 8 minus x squared. 8 minus x squared, 1, 2, 3, 4, 5, 6, 7, 8. It's an upside down parabola, right? And if I set it equal to 0, radical 8 and negative radical 8, something like this. And y equal x squared, well, that's simple. Something like this. Now, I want the area that these two include. Well, we're talking about this region. Two things I need to do. I know the area is going to be the integral. Do you notice if I draw my line, vertical line, the top is always the purple, which is awesome, which means that's 8 minus x squared, minus the bottom is always x squared. That part we got. I need to know what is this point and what is this point. That's when I take those and set them equal to each other. That's when I take x squared and set it equal to 8 minus x squared. 2x squared equal 8, x squared equal 4, x equal plus or minus 2. So this is a negative 2 and this is a positive 2. And if I say setup, do not solve, there it is, you're done. And if we're going to work this out, this is really 8 minus x squared minus x squared. So this is 8 minus 2x squared. So the antiderivative of that would be an 8x minus 2, add 1 to the power, divide by that, from negative 2 to positive 2. And that would be 8 times 2 minus 2/3 times 8 minus a negative 2 in there, and 8 times negative 2 minus 2/3 times negative 2 cubed. Of course, you could simplify that if you want, or just let the calculator do the work. Make sure you know how to use your calculator properly. And if I take parentheses 8 times 2 minus 2 divided by 3 times 8, get that answer, minus parentheses 8 times negative 2 minus 2/3 times a negative 2 cubed. 21.33, that's an acceptable answer. I could make that a fraction, but I don't have to. My calculator could do that. No need to worry about that. How about this problem? Again, I need to graph this. Yes, without a calculator. Cube root of x, that's like y equal radical x, and y equal minus that. And y equal x, so let me elaborate and make that a bit nicer. There. So we want to find this area and this area. Well, how does that work? if I draw my vertical line, I notice here the top is the line and the bottom is the cube root. Plus, here they switch around. Here I notice the top is the radical and the bottom is the line. How do I find these points? I set those two equal to each other. I set cube root of x equal x. If I cube both sides, because that's a cube root, x cubed equal x. If I get everything on one side 0 on the other side and I factor, so the basic algebra, I'll get x to be 0, 1, and negative 1. That is 1, that is negative 1, and that is 0. So it's going to be the integral from negative 1 to 0 and 0 to 1. Setup, do not solve, there it is. If I say work it out, well, let's work it out. That is x to the 1/3, so this is x squared over 2 minus x. Add 1 to 1/3, that's 4/3, divide by that. Evaluate it from negative 1 to 0. That would be, throw the 0 in, that's 0 minus 0. Throw the negative 1 in. Negative 1 squared is positive 1/2 minus 3/4. A negative 1 in there, since that's raised to the 4th power, that's a positive 1. Plus, and here I'll get the same thing, except I'm going to get x to the 4/3, divide by 4/3, you multiply by the reciprocal, evaluate it from 0 to 1, so throw the 1 in, you'll get 3/4 minus 1/2 minus 0. And I'm going to throw all of this in my calculator, and here it is. I'm going to take a negative 1/2 minus 3/4 plus 3/4 minus 1/2. I'll get a half. And I rearranged the furniture. I'm going to do this problem now. It says, use integration to find the area of the triangular region having the given vertices, a quick graph. And let's see how this works. This runs 0, 0, 6, 0, 1, 2, 3, 4, 5, 6, 0, to 4, 3, 1, 2, 3, 4, 1, 2, 3. So this triangle. Very simple to do. Well, what's the catch? I need the equation for those. I notice if I color code this, I notice here when I say I want to find the area, that's the integral from 0 to 4. I know it's the line, the orange line. I need the equation for that. And from 4 to 6, I know the line runs to the green. The top is green, the bottom is 0. So I need to find an equation for that. Well, this one is simple. We did that already. This first line, that's y equal mx plus bb is 0. The slope is you rise 1, 2, 3, and you run 1, 2, 3, 4. So this line is y equal rise over 1x. Got it. This line has a slope of rise 1, 2, 3 down and run 3 to the right. So it is y equal negative mx plus b. I need to find b. I'll take the point 6, 0, and I'll say y equals 0 when x equals 6. So b equal a negative 6, which means The green line has the equation y equal negative x. Oh, it's plus 6, right? When you move it over. So it's 6 minus x really. So this would be 3 over 4. Add 1 to the power, divide by that. And this would be 6x minus x squared over 2 from 4 to 6. This would be 3 over 8 times. Throw the 4 in, that's 16 minus 0. Plus, here I'm going to get 6 times 6 minus 36 over 2, that's 18. At 4, 24 minus 4 squared is 16 divided by 2 is 8. I could do this by hand, but since I'm allowed a calculator, might as well make use of the technology. So here I could say 8 divides 6 2 times. This is 36. Again, you could plug all of that in a calculator. 3 times 2, that's 6, plus 36 minus 18 minus 24 minus 8. And I'm getting an 8. And that would be this area that we just found. And the homework is right there on 5.5, number 1 through 7 odd, 5 to 23, skip number 17. On number 29 through 35, keep the same directions as 15 through 30. Just find the area, ignore all the remaining directions, and do number 41.